Welcome to points of inflection. So just a quick definition. A point of inflection of F is a point where F switches from concave up or down. Oh, let's just say switches between concave up and concave down. V and A got swapped. All right, concave, there we go, down. Just a note here, F has to be continuous at that point. So we can't have like an asymptote, right? So just a quick note. F must be continuous at that point. So around the point of inflection. So what we're looking at is we have a graph. And maybe our point of inflection is going to occur here at x equals c. So here's the point where it's going to swap. And so we may be concave up, so we have a scoop. And then we swap to concave down. So we scoop up and then have a cap down. So this is one version. We could also go the other direction. So this is switch from concave up to concave down. We could also go the other direction. So we could switch from concave down to concave up. So again, here's our C. We have our point. If we start as concave down, we start as a cap. And then we'll switch to a cup. So note the places where this can occur are only where we're switching between positive and negative for the second derivative. So this can only occur at the places where the second derivative is either 0 or undefined. So points of inflection can only occur where the second derivative, f double prime of x, is equal to 0 or is undefined. And so we've essentially been doing precisely this when we were just looking at concavity. We were already finding these places where the point of inflection might occur. Then we just need to check that the concavity switches signs. So, or we just need to check that the concavity changes. So it's possible for the second derivative to touch 0 and then go right back. So the sign doesn't change and therefore concavity wouldn't change. So these are just sort of the two things to keep in mind. And then just a point in terms of what it looks like. Note that if the second derivative at C is undefined, and there is a point of inflection, then what happens is that the graph essentially appears vertical at that point. So the graph appears vertical at x equals c. So what I mean by this, here's our x equals c. Here's our point. Essentially, we're going to come through and then basically go straight up just through that point and then cap off again. So it still is a point of inflection. It still looks more or less like what we had before, but here we're basically going vertically through the point at x equals c.